Hello, and welcome to an intro to Transition, a language that builds and runs state machines. It's specifically targeted at game development, especially in Unity, but it is not limited to that. All of this information for how to get started with Transition can be found on the GitHub repository. However, this video will be using the tutorial setting up in Unity as a basis for the code that we're going to examine. In this tutorial, we're going to be modifying a state machine to see how easy it is to work with transition and how easy it is to extend and add behavior to your state machines. Let's jump into Unity to see this state machine work. Here we have this ball, and it is controlled by a state machine with two states. The first state moves it to the right at one speed, and then the second state moves to the left at another speed. It's going to move between these two states over and over again. Let's just watch it work. And then we'll take a look at the state machine code itself. So as I said, it moves to the right slowly and then to the left quite quickly and repeats. Now we're going to take a look at the state machine code, which is here, but I'm going to do that in the Atom editor. That's because I have built a syntax highlighting package that you can find by searching for transition and installing transition-grammar. I already have it installed. You can activate it by either renaming your file with a .tx extension or just changing the grammar to transition. Now I'm going to gloss over a lot of the details about the state machine language. We're going to focus on the most important parts, the parts that make transition slightly different than a regular state machine system. It's somewhere between behavior trees and state machines and how the logic is run. So let's look at this starting with line number 1. The first line is a machine definition line. It's saying the name of this machine and the first state to transition to. This arrow means transition. So if we look at move right, it has a special section called run. Within this section, there will be a number of actions that will be run one after another. Some actions can take multiple frames or multiple ticks to run. In this case, we have a move action, which moves the ball at a speed of 5 to X position 5 on the screen. Once it reaches that position, it'll move to the next action, which happens to be a transition to the state move left. Move left is a state similar to move right, except it moves at a speed of -20, that's left at a speed of 20, to the position X equals -5. And then after that is done, it moves to the right, or rather it moves to the state move right. Now let's just to show you an example of modifying a state machine, I'm just going to copy and paste it into this machine manager script, which you can find in the tutorial that I mentioned at the beginning of this video. I have increased the speed from 5 to 50, and as you can see, it moves very quickly now. One of the more interesting parts about transition is the reusable logic. And I'm going to demonstrate that by moving the ball at one speed up until X equals 3. And as it approaches 5, I want it to go very slow. In fact, we'll make it go even slower. And then after that, it will move to the left. If you make actions such as the move action in such a way that they're reusable, you can make it very easy to change behavior, to try out new behavior, or to make all completely different state machines using the same set of components, just ordered in a different way or with slightly different parameters. As you can see, the ball is moving to the left at its normal speed, and as it approaches from 3 to 5, it gets very slow. So that's pretty easy, just taking the current actions that are here and kind of moving them around. But let's see what it would take to add functionality to our state machine, brand new functionality. What we want to do is when the state is entered, we want to scale the ball by 2 when it's moving right, and when it's moving left, we want to do the same but in half. And so the effect that this intersection has is that when a transition occurs, this state will run all of the actions in the intersection. before ever starting with run. There's also an exit and another section for catching messages, but we can get to those in a different tutorial. For now, let's try and just run this. The compiler said that could not find action for name scale. That's because the code that powers this action doesn't exist yet. Let's make that. And we'll make that by taking a look at the move action that has been moving our ball left and right. And we will try to use it as a template for a new action. So I'm just going to copy this. In fact, I'll copy it like this. Paste it down here. Rename to scale. And refactor it and by moving it to another file and opening up that file. So here we are. We have a scale action, and we'll remove all the logic. Now, scale is an action that takes a parameter, so we must give it a parameter here. Let's call it a public. We'll just call it val. And because I don't want to have to type the word val, I'm just going to add a default parameter attribute, which will allow you to avoid typing this. Now the tick result, or onTick method, is the method that is called when the state machine runs for a single frame. The state machine's logic is organized into a series of ticks. So let's add the logic now. An action is passed a context, and in this particular context, we have a transform for the object we are controlling, which is very convenient. So we can say context@transform.localScale times equals val. That will scale our object. And now we need to inform the state machine of what action to take next. To do this, we must return a tick result. And here I'm going to return tick result.done, which tells the state machine to move to the next action immediately. There are multiple tick results like loop, transition, yield, and a special one called yield done. Those are for another tutorial, or you can find the information for those in the documentation. Now that we've done this, there's one thing that we need to do, and that's to add this type of scale to the machine controller.load actions. What I'm doing here, the explanation can be found in the tutorial I mentioned at the beginning of this video, but it's basically saying that before you compile, I want you to know that you might see a scale action, and when you see that, you should use this class to instantiate it. Now, back in Unity, let's see if this works. As you can see, it got bigger. And now it's going to get smaller and go to the left. So if we take a look here, it worked just as we thought. Before it moves right, it scales by 2. Then it does all the moving. Before it moves left, or once it does transition to moving left, it scales it in half and does all of the moving again. Now, there's one last thing I want to show in this tutorial, that this logic could have actually been organized in a different way to make it a little bit simpler. And it all depends on how you want your states to work. And I'm going to demonstrate that by moving all of this logic from the move left state into the move right state. You see, instead of transitioning to move left, we could have just used the keyword loop, which will start the state over at the beginning of, at the very first action on the very next tick, on the very next frame, that is to say. So let's paste that in here and see that in action. And as you can see, it's bigger and it's moving to the right. Then it moves to the left at a smaller size. It works just as before. So that's it for an intro to transition. Please check out the wiki or leave comments in the video comment section below.